All right, so let's look at the notes on pulleys now. All right, so this is our second type of simple machine. In the case of a pulley is a grooved wheel. All right, why is it grooved? It's so we can usually run a rope over the top of it. It's very similar to a first class lever, because if I have my first class lever, if I attach a string on this end and take that down and put a weight on it, and in this end I put a string on it and I pull down on it, when I pull down on this, then it's going to lift that object up. All right. What you have to think of is that I pull down on this, right, and then I pull down on it, and I pull down on it, and I pull down on it, and pull down on it. What I end up with is I end up with this spinning thing, right, which is really like a wheel. And all that happens is we got this rope that's going to the top of it, and it comes down, and I'm pulling down on the rope, and it keeps lifting the object up on the other side. So really all that's happening in the case of a pulley is it's simply just a lever, but it's a continuous lever that's constantly going all the time. All right. So the drawing that you're going to make is exactly that. We get this fulcrum, all right, and then we have a rope come down here to a weight, and then over here we got another rope, and this is where the person is, all right, that's holding on to the rope and pulling down on it. And as they pull down, what ends up happening is you end up with this. You end up with a wheel, right? And the rope goes over the top, and as you pull that rope down, it keeps lifting the object up. And it's just this continuous, constant first-class lever, right? Now we look at this idea and go, okay, what's the mechanical advantage on this? Well, this distance over here is equal to this distance. So if this is 20, that's 20. If you remember in the last piece of notes, we said it's we divide the 20 by 20, so we'd end up with a mechanical advantage of 1. So if I have this pulley hanging from the ceiling, and I'm going to pull down on something trying to lift it up, then I get a 1-to-1 ratio. If this weight weighs 100 pounds, I got to put 100 pounds of force into it in order to pull it up. Right? So this pulley, this is the next part, is the types, is a fixed pulley hanging from the ceiling. Right? It doesn't move up and down, it's just sitting there. All right? The mechanical advantage of it is a 1, and that's because the length of the effort is equal to the length of the resistance. All these pulleys do is it changes the direction. It doesn't multiply force. It makes it easier for me. I can pull down in order to lift something up. That's all it does. Okay. Now there's a different type of pulley, and what this pulley does is it's called a movable pulley. And what happens on this one is now the pulley is down here, and here's my object, right, that's hanging from it. And then what happens is, and I'll use a different color, is that I have this rope that comes down, goes around, goes back up, and it's attached up here, right? And then over here is the person that's pulling up on it. And he's trying to pull this thing up, this weight up, using this pulley that's hanging down over the top, over this. Well, as he pulls this thing up, again, we're going to look at this as a lever, okay? As he pulls this thing up, this spot over here, that's my fulcrum. All right, this spot over here, that's me pulling this up or you pulling it up. So what's in the middle? Well, in the middle is this weight. So that's resistance is in the middle. So I got to think about resistance. Well, let's see, I gave you a free answer in the last set of notes. So it was fulcrum, resistance, effort, right? Resistance is the second one, so that means this is a second class lever. And if you remember a second class lever, that was like the wheelbarrow idea. It makes it so it's easier to lift up that 100 pounds of rocks. And I can do it with maybe 50 pounds worth of force. So this thing here, here's my distance of the effort, here's my distance of the resistance. So I really have 2 times the distance of the effort over 1 time of the resistance. So that gives me, if this is 40 for effort and resistance is 20, 40 divided by 20 gives me a mechanical advantage of 2 in this case for this one. All right. And then mechanical advantage of 2 means if this weight down here has a mass of 100 pounds, and I only got to exert 50 pounds worth of force into it in order to pull it up. Okay. So the second piece of notes there says a movable pulley does move up and down. So as I lift this thing, this pulley is actually going to move up and down on this in the air. The effort distance is twice the resistance distance. Now, how do we end up deciding what the mechanical advantage is? We can do this mechanical thing here, but I'll give you a faster and easier way to figure these out. All you have to do is count how many ropes there are on the pulley. So you got 1, 2. So there's 2 ropes, so it's mechanical advantages 2. All right. Now to give you another example of something like this, let's get rid of this person here. And we're going to kind of change this a little bit. And if all of a sudden I put a second fixed pulley up here, so this is a fixed pulley at the top that's not moving, and now what ends up happening is this rope comes up here and attaches at the middle. Right? And then this pulley comes up here, goes over the top, then it comes back down and goes around a second pulley, and then it goes back up, goes around, right? And then it comes over here to the person, and it's going to be holding on to it. So when he pulls on this rope, what it's going to do is it's going to cause this pulley to move back up, and it's going to lift this. But what's the mechanical advantage of this one now? What we got to do is we got to count the ropes that are between the 2 pulleys. So we got 1, 2, 3, 4. So there are 4 ropes. So the mechanical advantage of this one is a 4. What does that mean? If this weight down here is 100, how much force does this guy got to put into it? Well, only a fourth. So he's only got to pull with 25 pounds worth of force in order to lift 100 pounds. Right? So it makes it a whole lot easier. But now the thing that we're going to learn coming up down the road here is that, and I'll finish this and we can still see, is that he's going to have to pull a whole bunch more rope. Right? He ends up having to pull 4 times as much rope as what it takes to lift this. So if he wants to lift this thing a foot, he's got to pull 4 feet of rope off the end. Right? So you kind of give and take on this. You get to lift something that's really heavy, but you're going to have to pull a whole bunch of rope in order to make it work. All right, well that concludes these notes on this one. So we'll talk to you later. See ya.